Hello, my name is Abel Duprat, and I am an undergraduate research assistant at Northern Arizona University. Today, we are going to review the configuration keys as well as parameters and model specifications for PyBioNetFit. PyBioNetFit is a software package that supports parameterization of biological models that is being developed at Northern Arizona University and Los Alamos National Laboratory. Documentation about the software is provided below. As you can see, I already have the documentation open here. In our previous videos, we went over how to install PyBioNetFit on a computer running either the Windows 10 operating system or the Mac operating system, as well as how to configure a simple fitting job to run on PyBioNetFit. Those videos covered these three sections here: installation, quick start, and configuring a fitting job. Today, we're going to go into the configuration keys category and go over some terms and specifications. All right, so I'm going to open up the configuration keys. And this first section here goes over the configuration keys that are required in order for your config file to run. And the first topic discussed under required keys is the model. And the model specifies the mapping between the model files, our BNGL files, and our data files, which would be our EXP or our prop files, or it could be both. I'm going to open up a config file I have as an example to kind of try to simplify what this is describing here. So towards the top here, you can see I have my line for my model written out. And as you can see, it is written out as model space equals space, the name of my BNGL file, including the extension, followed by a space, a colon, a space, and then the name of my data files. So this example did not have any prop files on it, so it only shows the name of the EXP file with the extension. But if I had multiple EXP files or if I had prop files as well, I would indicate them just with a comma and a space. So an example would be, if I had a prop file, I would do a comma space, and let's just make one up. But if I had this file as part of my job, it would be represented like this. And like I said, multiple ones would just be added on with a comma and a space. So here, if I had both an EXP and a prop file, they would just be EXP file, comma, space, prop file. And that's how you would add your model line onto your config file. Next, we have the fit type. The fit type sets the type of algorithm that will be used in our job. These are different methods for calculating the best guessed number. Depending on what the job is doing, some of these may be faster than others at different times. And as you can see on the left side, we have the abbreviation of what type of algorithm. Some examples: DE would be used in our config file to represent differential evolution, SS to represent scatter search, and so on. If I go back to my config file, I can show an example that I was using the fit type to be scatter search. So I had fit type equals SS. So if we continue down the list, we next will have our objective function. All algorithms use an objective function in order to evaluate the quality of fit for each parameter set. That objective function is set via the objective function key. Once again, as you can see, there's a few options here. The abbreviations for them on the left side and the right side listing what they are. So I'll go back to show, but as you may have saw, I had the SOS set as my objective function key. That represents the sum of squares. SOD for sum of differences, and so on. So let me open up that configuration file again, just to show you that below my fit type, I did have my objective function equals SOS. So my fit job was set to use a sum of squares as the objective function. And these last two required keys here are population size and the max iterations. And these two kind of go hand in hand with each other, but the population size is the number of parameters sets that are to be maintained in a single iteration of the algorithm that we've set. While the max iterations is how many times a population is to run. The result from the previous iterations informs the next iterations. So let me show you kind of what that looks like in my configuration file. So down here, you can see I have a population size set to equal 20 and a max iteration equal to 30. So I'd have the population of 20, and each iteration will run a new set of 20. And that'll run 30 times. So that's where these two are set in your configuration file. Okay, so now we are done with our required keys, and we are moving on to other path keys. And so here we have two keys, the BNG command and the output directory. So the first one that I will talk about is the BNG command. And this is the path to the bng2.pl file. This is required if your fitting job includes any BNGL files. If the path has previously been specified using the setx bng path command during the installation of PyBioNetFit, then this line does not need to be specified. But if it was not, or if the file has been moved, then we would use this command to indicate its location. And so I'm going to open my configuration file to show you what that would look like. And so this line here is what that would look like. And as you can see, it is the BNG underscore command equals, and then this is the directory path for where that file is. And how you would do that, or how you can indicate this on your computer, is if you open the File Explorer, and that is, I have it on the taskbar here, but the File Explorer on your Windows 10 computer. And I'm going to go to where that file is on my computer. The path may be different on yours, but mine is saved on my desktop in this BioNetGen folder, this folder within that folder, and then I can see the bng2.pl. And so what I did was I went towards the top here and I right-clicked on the folder to copy the address. And then if you went back to the command line in your config folder, what I did was I had just pasted in place, and I added the bng2.pl at the end. And there are different ways to do this, but I just wanted to show you the way that I did this. And so this is how you would set your BNG command on this line here. But once again, it may not be required if you had already set this during the installation of PyBioNetFit. So let me close this. I will exit out of the File Explorer to discuss the output directory. And the output directory, this indicates where we should save the output folder. As you can see, there is a default for PYBNF underscore output, but if you wanted to specify an alternative like I did, you would put an output underscore dir equals, and then the directory name where to save those results. going back to my configuration folder, my configuration file, just to give you an example, you can see below my BNG command, I have the output directory, and I had it set to create an output folder, and then within that output folder, I had a demo_BNG folder, and all my results would be saved into there. But like I said, if you do not have this line, then the default would be this folder to be created for you. And so those will be the other path keys, which are not required, but may be used. But if they're not used, there are defaults set for them. So now, if I come down to our parameter and model specifications, let us start with the uniform variable. So a bonded uniformly distributed variable defined by a set of 3 that corresponds to the variable name, the lower limit, and the upper limit. When a U is added after the upper limit, it means that the limits are only enforced during initialization, but not during fitting. So the example used here is uniform_var equals the variable, in this case, it's the k_free, space, the lower limit, which in this case was 10, space, the upper limit. And on this top example, that would be all you would need. But like we said, if you wanted to add the U at the end, you would do a space after the upper limit and add the U. And once again, that means that these limits are only enforced during the initialization, but not during the fitting. Below this, we have the normal variable, which is a variable defined by, once again, a set of 3. But this set corresponds to the variable name, d_free in this example, the mean value indicated by numeral 10, and the standard deviation indicated by the numeral 1. And I'm just going to scroll down to keep pace here. But next we have the log uniform variable, and this is a variable that is distributed uniformly in logarithmic space. So the syntax is similar to the uniform variable, which was the variable name, the lower limit, and the upper limit. So you can see that here. And then similarly, if you add a U at the end, then those limits are only enforced during the initialization, but not during fitting. So you can see variable, lower limit, upper limit. Now during the log normal variable, which we have here, a variable is normally distributed in logarithmic space, and the syntax is a set of 3 containing the variable name, the base 10 log of the mean, indicated by numeral 1, and the base 10 log of the standard deviation, indicated by 0.1 here. Okay, so now to review, we went over the required keys that need to be in your configuration file in order for your configuration file to be ran with PyBioNetFit. This included the model, the fit type, the objective function, the population size, and the max iterations. We went over optional keys that can be used to specify changes that you would like to be made, but if they were not used, there are defaults that would be set for them. Those were for the BNG command and for the output directory. And then we went over the parameter and model specifications, which included the uniform variable, normal variable, log uniform variable, log normal variable, and the log variable. And those were the model and parameter specifications. And these were all configuration keys that could be found in the PyBioNetFit documentation. Thank you. So long.